Video number 154. We're going to use the trig identities to find function values. Now, trig identities, a lot of people are scared of them. Please, they're very, very easy. In fact, these 5 trig identities we kind of already know how to do. Watch this. If you take a look at the equation of the unit circle, let's take this unit circle here. It's got a radius of 1. We know that any point that's on the circle, it's going to have an x value, y value, right? X, y. Okay? It's got an x distance to the right, y is the height. Any point that's on the circle is going to go by this equation here, x squared plus y squared equals 1 in the unit circle. What's awesome about this is this. We could think of the x value as cosine. The y value is sine, sine, and then 1. Guess what this is? Trig identity, number 1. Sine squared plus cosine squared equals 1. It's just simply the Pythagorean theorem. Then what you could do is we could actually think of this in other ways. If we wanted to, instead of using 1, you can use an r. So this applies to other circles that have a radius other than 1. And what you could do is you could just go through and divide by various amounts. For example, let's just say you went through and divided the whole thing by x squared. What would you have? You'd have 1 plus y over x quantity squared equals r over x quantity squared. Well, let's change that to the trigonometry. Well, this is a 1 plus, well, what's y over x? Rise over run, which is tangent squared. Alright? What's r? That's the hypotenuse. R over x. Hypotenuse over adjacent. What's hypotenuse over adjacent? Well, what's adjacent over hypotenuse? Adjacent over hypotenuse is cosine, therefore this is what? Secant. Trig identity number 2. There it is. Tangent squared plus 1 equals secant squared. Let's go back to this equation of a circle again, and instead of dividing by x squared, alright, we'll go ahead and divide by y squared. Divide the whole thing. What are you going to have? X over y quantity squared plus 1 equals r over y quantity squared. Alright, what's x over y? Well, that's not tangent, that's what? Cotangent squared plus 1 equals hypotenuse over opposite. Hypotenuse over opposite is cosecant because it's the inverse of sine. Cosecant squared. Guess what this is? Trig identity number 3. Alright, then of course, tangent is equal to opposite over hypotenuse. So opposite over hypotenuse, and then cotangent is just adjacent over hypotenuse. Alright? So, there's your 3 basic trig identities. Let's continue here, ladies and gentlemen. Find the other 5 trig identities given the other 5 trig function values. There you go. Given that cosine theta equals root 5 over 8 and tangent is negative. Alright. First thing we do is we use the sine squared plus cosine squared equals 1. So, use this formula right here. Plug in the cosine theta. It's squared. Cosine squared means square this. Alright. That gives you 5 over 64. Subtract 5/64 on both sides. Square root. Sine is equal to plus or minus root 59 over 8. Now, since tangent is negative, from here, we're dealing with either quadrant 2 or quadrant 4. Remember. Oh, that's quadrant 1. Okay, so you're dealing with one of these 2 quadrants here. That's quadrant 1. This is quadrant 3. So we're dealing with either 2 or 4. Then, we then say, okay, since sine is negative, we say sine theta is negative. Why? Cosine is positive. Right? They tell us this cosine here is positive. Where's cosine positive? Well, cosine is x. X is positive here and here. Therefore, we're definitely dealing with quadrant 4. Next thing we have, the answer to all 6. Well, since Sine theta is definitely negative root 59 over 8. Cosine is root 5 over 8. Bam! We start off here. Tangent's equal to sine over cosine. So what did I do? Root 59 over 5. Just take the numerators, divide them out. Then we just rationalize the denominator. We get negative root 295 over 5. Alright, cosecant is just the inverse of this. Flip it over, rationalize the denominator. It's still negative. Secant's the inverse of cosine. 8 over root 5. Bam, 8 root 5 over 5. Cotangent is the inverse of tangent. Flip it over. Negative root 259 over 59. All right. Let's continue. Next one. They tell us find the other 5 trig function values given that cosecant theta is negative 3 and cosine theta is positive. All right. We're going to use the 1 plus cotangent squared identity. Why? Because they tell us the cosecant. So we're going to use this one to help us figure out cotangent. All right. So we plug in the negative 3 here, right, for cosecant. That just gets squared out. You get a 9. You subtract 1, you get 8. Square root, cotangent equals. Now I put down negative 2 root 2. Why? Because cosine's positive. Right? Cosine has to be positive. Where's cosine positive? 1 and 4. Therefore, we're dealing with cotangent has to be negative right here, because that's what we solve for. So here's the deal. When we do this square root, we're deciding, it says plus or minus. So we're figuring out, is it plus or is it minus or is it both? Well, cosine has to be positive, so therefore we're dealing with 1 or 4. Then, because tangent's negative, we're only dealing with quadrant 4 because tangent's not negative in quadrant 1, quadrant 4. Now, cotangent would be equal to cosine over sine because tangent is rise over run. Therefore, cotangent would be run over rise. So then, we then can say, since sine theta is negative 1/3, we just plug negative 1/3 in for the denominator. All right. Then we plug in the negative 2 root 2 for cotangent. We multiply both sides by this fraction. Or in other words, move the 3 up here actually. Just move the 3 up, negative 3 up there. Divide both sides by negative 3, and cosine is equal to positive 2 root 2 over 3. Bam! Alright. So, then this allows us to answer all the questions. There's cosine theta. We move that in right here. We were told, we figured out sine theta. Actually, we knew sine because cosecant's negative 3, so therefore sine is negative 1/3. Bam. Tangent we figured out because what we could do is we could take cotangent and bam, do the inverse of cotangent, right? That's from here. So therefore tangent's this one. And then you just rationalize the denominator by multiplying both by root 2 over root 2. So it'll be root 2 over 2 times 2, 4, bam. Cosecant's the inverse of sine. Okay, secant's the inverse of cosine, so we're going to flip this guy over. That'll give us 3 over 2 root 2. Rationalize the denominator, 3 root 2 over 4. Cotangent is the inverse of, bam, tangent. So you go back to this one. You don't go back here and flip this over, then you'll have to rationalize the denominator. So you go here, flip that one over, bam, negative 2 root 2. Questions or concerns? Send me an email. Good times.